Yeah, hi everyone. So in this video, we're going to be solving one of a foundation problem. So here is the problem statement. So we'll be given an array of integers, and we have to check whether there exists any triplet. Triplet means a pair of three elements whose sum is the expected sum. Suppose if we say x. So for example, here in this example, we have an array of integers which have 3, 7, 1, 2, 8, 4, and 5, and the sum as given as 20. So this is the expected sum. So in this array we have to check whether there exist any three elements. So three elements should be distinct whose sum is equals to 20 or not. If it is if there is exists any triplet such that we have to return a boolean, say it as true. If it not, we have to return as false. Yeah, so here we can see if we take 7, 8, and 5, their sum will be equals to 20. So there exists a triplet with some 20 in the given array. So we will be returning true. So this is what the problem state is all about. So now we'll see two approaches to solve this problem. The first approach is a brute force approach. So it will have a higher time complexity. So the idea of this algorithm is we have to we'll go through all the three pair combination of elements, and while we are going through we'll check the sum of the three elements. If it is equals to the expected sum, we'll be returning true. If it is not, at the end after checking all the pairs and their sum will be, if there doesn't exist any pair with expected sum, we'll be returning false. So that is what the idea of this brute force algorithm is all about. We'll be going through all the triplets from the which can be made from the given array, and we'll be checking some. If there exists any triplet, we'll be returning true. If not, we'll be returning false. Yeah, so that is the idea. So here is the computer program for this algorithm. So this is written in Java language. So here, so the way we are, I will go through all the triplets from the given array is by using three loops. So the first loop will be iterating all the way from first element and the last element using a variable called I, and in the inner loop we'll be looping from I plus 1 all the way to last element, and in the innermost loop we'll be looping from j plus 1 all the way to the last element. So the first loop will start from whenever whatever the I can take. The next inner loop will start from I plus 1, and the innermost one will start from j plus 1. J plus 1 essentially means I plus 2. So that's how we're gonna be going through all the triplets from the given array. So if you see this Java program here, this is the method is triplet exists with sum, which has the main logic to check to solve this problem. So which takes an input as sum and other input is array. So over here we are doing the three loops as we have discussed just now. We have three inner loops, three nested loops. So and inside the loop, inside the innermost loop, we are just checking the sum of all the elements of the array. So and then if there exists any element, if there exists any triplet whose sum is equals to the expected sum, we will be returning true. And after this entire nested loop is done, we will be returning false, because if there exists any triplet, it should have already written through here. If there is, if it has not written, it means that there doesn't exist any triplet. So so this is the Java program for this brute force algorithm. So we can do one little change for this program, which is that we, as we have seen, we are looping zero I all the way from first element to last element, because we don't need to do that, because the last triplet or the triplet with highest value of numbers will be like n minus 3, n minus 2, and n minus 1 index. So this 3 n minus 1 n minus 3 index, n minus 2 index, and n minus 1 index. N minus 1 index is nothing but the last element. So this is the last triplet which we can find from this given array. So it means that I can only go up to n minus 3, and j can only go up to n minus 2, and k can only go up to n minus 1. So we can do this change in the loops rather than looping all the way from 0 to all the way to last element. So and inside this we do the same. We'll check the sum of the elements of the three elements, sum of the value of the three elements. If it is so, if it is so, to expect of sum, we'll be returning true. Otherwise, at the end we'll be returning false. So even if we go to last element, doesn't change anything, because if we see here, if I equal to n minus one, then j equal to n, right? So it won't go inside it. So even if I equal to n minus two, so j will be like what is it, n minus one. So it will go through this loop, but when we come here, the k will be like what is it, n. So n doesn't is not less than n, right? So we won't go into this. So even if we go to last element or don't go to last element, it doesn't matter, because only thing if we change the last elements, the only thing which it does is not to do the additional checks. So both, in either case, both programs does the same. So this is what the brute force is approach is all about. Go through all the triplets and check if there exists any combination whose sum is equals to expected sum or not. So the time complexity of this algorithm is like big O of n cube. So this is because we have three inner loops in our nested loop. So that's why the time complexity is big O of n cube, and the space complexity is just big O of one, because we are not creating any data structure here. Yeah, we are not populating in data structure, so that's why the space complexity is constant, which is big O of one. Yeah, so now we'll go through a 2.0 technique. So using this technique, we'll be reducing the time complexity of the algorithm. So the idea of this approach is, so since we have to find a pair of three whose sum is equals to expected sum, what if we fix one value of the triplet? So then the problem will be like if you fix one value of the triplet, then the problem should will be like to find a pair whose sum will be like expected sum minus third element. So this is the idea of this approach. We'll be fixating one value of the triplet such that our problem will get reduced to finding a pair whose sum equals to the expected sum minus third element. So essentially, we are making the triplet. We are making the problem whose to find a triplet whose sum equals to expected sum, to finding a pair whose sum equals to this value. So we are making this problem to finding a pair problem. So as you already know, if you have already solved this problem to find a pair whose sum equals to expected sum in a given array, it will be very easy to understand this. Or else we will also go through this approach here as well again. So that is the idea of this second approach. So to achieve this, what we're gonna do is, first we will be sorting the array. So we'll shortly see why we are doing the sorting, and then we'll be running a variable from all the way from first element to the last element of the array. So in each iteration, we'll be assigning the value pointed out by the variable loop variable as one element of the triplet. So and then we'll be searching the remaining two in the right hand portion of the array. So essentially, what we are doing is we are just looping all the way from first element to last element. So and we are fixing the value of one element of the triplet as the value pointed by the loop variable in the array, and then we're going to be searching for the remaining two elements. We are searching for the pair in the right hand portion of the array. So why we are only searching in the right hand portion is because if there exists any element in the left hand side which will be part of triplet, we would have already found it, because as I said, we are starting the loop from first element all the way from left to right, right? So when we are fixating each value, the loop variable points to in the given array as one of the element of triplet. So if there exists, it means that the values which are left to the loop variable already have been fixated as a triplet, and we have already have checked whether there exists any pair whose sum equals to like expected sum the value minus the value of that element. So it means that there doesn't exist any triplet whose where we have the value as one of the value to the left of the loop variable. So if there exists any loop triplet such that we would have already got, we would already found it. So due to this, we will only search for the for remaining two in the right hand portion of the array. So this is the idea of this approach is about. So here we will see the computer program for this algorithm. So this computer program is written in Java language. So here the method which we call first is this method is triplet exists with sum. So this method essentially takes two parameters. One is the expected sum and the other is the array. So here first we are doing the sorting. So we'll shortly see why we are doing the sorting. Sort the array, and next we'll be starting a loop to iterate all the way from first element to last element of the array. So n is the length of this array, and then inside we'll fixate one element of the array, one element of the triplet with the variable with the value pointed by this loop variable. So it is like when a loop variable is I, so we'll be making the with our expected target or expected sum will reduce to the sum minus value of this array. So now the problem will be reduced to finding a pair in this array whose sum equals to this target. So our problem will got reduced to finding a triplet to finding a pair whose sum will be like target. And also we have to find this target only in the right hand portion of the loop variable. So now, suppose this now we are at a position where I is pointing to the ith position of this array, right? So we essentially need to only search for the pair from I plus one position. It means that from the right hand position to this ith variable. So essentially, we have to find if there exists any pair in this I, starting from I plus one position, whose sum equals to the target. Yeah. So now for here we will be calling this method is pair exists with sum. So this method will essentially take three parameters. One is the expected target, expected sum, and the other is starting point, and the other is the array. So we have to find a pair whose sum equals to a target starting from the this index. So to solve this problem, we'll be using two pointers. So one which is already we have this. This is the position from where we start searching from. Another pointer will be which will start from the last element of the array. Yeah. So then we'll be looping all the way from the starting point. Starting point represents the index of the array, and all the way to the jth index. So and inside and while we are iterating it, we'll be checking if the element at starting point and the element at jth index is equal to target. If it is so, we'll be returning true. So if not, we'll be checking if the element at starting point and plus element at jth index sum is less than target. Means that since we have already seen that we have already sorted this array, right? So the sum of these elements is less than target. It means that we have to increase the value. We have to increase the value of one of the pointer. So we'll be increasing the starting point to right side, such that as array is already sorted in ascending order, when we increment the starting point, it will essentially take a bigger value than what it has already took previously. So if sum is less than target, we'll be incrementing starting point, and if sum is like greater than target, we have to decrease the value of one of the value. So then we'll be decrementing this j. So the idea of this approach is to increment starting point and decrement j. So while doing so, we'll be checking. We'll get closer to the target sum. So we are here. We are essentially using the information that the array is already sorted. So since array is already sorted, we are just incrementing. We are smartly incrementing the pointers rather than going through all the two pair combinations. Yeah. So whenever in this loop we'll reach a scenario where element pointed by starting point and element pointed by the jth index is equals to target, will be returning true. Otherwise, we'll make sure we'll move the pointer such that we'll get closer to the expected sum. And if and at the end of the loop, we'll be returning false, because if there exists in a pair with sum equals to expected target, it would already been written a true here. If not, it doesn't means that there doesn't exist in a pair, so we'll be returning false. So here is this. So then here, if it returns true, we'll be returning true over here in this method. At the end of this loop, we'll be returning false. So this is how this entire approach is about. So here we are not directly returning the value which is written by this method, because we are executing this method for every loop, right? For every iteration, for each iteration. So this essentially this value, the method will be only true for one of the in one of the iteration. For other iterations, then definitely false. So we don't want to stop this stop checking for the algorithm when it is false in one of the iterations. We have to keep going on checking. So after we are done with the entire checking the entire array, then we can return false at the end. Yeah, so this is what this approach is all about. We have reduced the problem of finding a triplet with given sum to a problem of finding a pair with given sum. So this is what this second approach is about. So over here we have reduced the time complexity when we compare it to the first brute force approach. The time complexity will be like big of n cube n square. So since we have one loop over here, and then we are inside this we are executing this method. So in this method we have another loop. So the time complexity essentially will be like big of n square. So big of n square, as we all know, it represents the worst case time complexity, and the space complexity is a constant because we are not populating any, we are not creating and populating any data structure, right? So it will be like big of one. Yeah. So this is what this solution to this problem statement. So I will also attach this sheet which I have had here in the description of this video, so that you can go through. So in this sheet you can also find all the other problem statement which can be essentially solved using this pointers approach. Yeah, so that's it for this video. See you in the next.